We were preparing for this episode, and one of the things that I found absolutely terrifying was,
I'm telling you, the world went nuts down here. I mean, you had rednecks filling up the back of pickup beds with gasoline. The biggest threat still is the insider.
I was pretty surprised, and it really was an eye-opener for me.
I'm trying to understand what I just inherited. It stopped production, didn't it? We're fighting a business model now.
Hi and welcome to another episode of the Cloud Architects podcast. Today, with things that go bang or boom, depending on which country you're in and what happens to be exploding. Today, I'm here with Chris Goosen and Warren Dutoy, my co-hosts, and we have got the great pleasure of talking about OT security and things that can go bang with Roger Hill, who is the founding partner of Hillstrong Security Group. So Roger, welcome to the podcast.
Hey, thanks, Nicholas. Glad to be here.
And by way of introduction, Chris was in Israel a couple of years ago at the Blue Hat conference. And Chris, you saw something that scared the pants off you. Do you want to talk about that for a second?
Oh, yes. Yeah. No, I just happened to stumble into a session about sort of OT and OT security. And I thought, we all know what OT is, right? I mean, we have Raspberry Pis all over our house, our homes, and it automates some stuff for us. And they just do that at larger
Warren.
Well, that's it. And they just do that at larger scale. So, what more is there to know? Well, I tell you what, I was pretty surprised, and it really was an eye opener for me. And we thought, well, this would be a really good topic for us to to break into, and so we found someone who knows all about it, and of course we invited Roger along. So Roger, I think just real first thing, do you want to give us a quick introduction of who you are and sort of your background, in this space?
Yeah, sure. So my name's Roger Hill. I've been in this OT segment long before I think IT came up with the name of OT. I still remember the first meeting when I had to, what's OT? So I've been in the industrial space working for some of the large companies such as Siemens and Rockwell Automation for almost 20 years between the two of them, with a stint of a tech startup of my own in that time frame. So first of all, I think when we look at that segment, what are those segments? So within the discrete manufacturing and process automation, that's really manufacturing, whether that's assembly of automobiles, whether it's general manufacturing, consumer packaged goods, pharmaceutical, to the critical infrastructure side of power generation, transmission distribution, water treatment. It's all of the things that are providing all of this services and producing of equipment safely and efficiently that you just never think of. So it's the world I've been living in for going on about 30 years, and I just love it because I'm never bored.
Sorry, Chris.
I was going to say, I think it definitely sounds like a little bit more complex than just a few Raspberry Pis hanging around.
Yeah, exactly. So if you take the example of a production line that's automating producing a product, how that's automated. If you ever watched the show, I don't know if you have it down there, How It's Made, kind of a documentary. My kids hate it when I have that show on because I always have a story to go along with the episode. It's like, Dad, no. But it's absolutely fascinating when the human ingenuity meets engineering to automate processes. And it starts with typically a machine that's producing a product that's connected to another machine, maybe with some conveying, and then pretty soon you have an entire production line where you're automating the production of that product. But it's not just doing things quickly; it's doing things managing quality control and safety. So combining all of these together in this global competitive market, we're seeing more and more automation, and with the digitalization initiatives, that drives, you need to have faster decision making at the shop floor to be competitive. It's just a fascinating time in a fascinating world.
We were preparing for this episode, and one of the things that I found absolutely terrifying was how exposed OT systems are in terms of just general security, and that a lot of the security was security by obscurity, as opposed to security with well thought out and well instrumented controls. And that when adversaries understand enough about processes to interfere with them, we become incredibly vulnerable to attack, because it's really difficult to secure a lot of these services because they weren't designed to be secured.
It's worse than that, Nicholas. No, so it's absolutely true. The whole
That's not
security.
reassuring at all.
Well, listen, the good news is that it's a solvable problem, right? So yes, I think going back, there's an interesting timeline, and that's looking at the Stuxnet attack, right? So
Yes.
the world can really be divided into pre-Stuxnet and post-Stuxnet. So I think when you look pre-Stuxnet, absolutely there was really not a concept of secure by design, because when you look at some of the system tests that would occur, it was around all of the engineering principles of the automation system. So when someone intentionally attacked a system, the first question was, why would someone do that? From an engineering perspective, that just didn't make sense. It wasn't a consideration, right?
That's right.
So I think that's where I think a lot of the automation vendors really started focusing on the product security and really security by design. But now you have the bigger challenge is the life cycle of these systems. Now you're looking at 12 to 20 years. So even in that post-Stuxnet world, if you started to have new products that were secure, well, the reality is you have to look at when are those products being replaced. And by the way, when you're looking at a manufacturing line, let's say you've got 4 production lines. The reality is you're not going to shut down the plant to do a refresh. What happens is you typically have a 4 to 5 year CapEx project. Year 1, you're replacing, upgrading production line 1. Then year 2, production line 2. Oh, and by the way, when you're going with the new equipment, what you're having to do is almost downgrade the industrial communication protocols, because it still has to communicate and be cross-compatible with the older lines. Now, at the end of that 5-year period, when you've upgraded every single line, are you going back and actually re-enabling and reconfiguring the advanced capabilities of those controls?
Because it works. Why would you fiddle with it if it works?
Exactly. So it's a bigger challenge. It's a bigger challenge.
And generally, these environments are mostly disconnected anyway, though, right? Because, like,
But are
Nick,
they?
you and I have done some work for a company like way out that side in the past.
With nuclear reactors.
Yeah, and those were like completely segregated on purpose. Those were designed to be isolated and disconnected, and
They're
like
required to be. They're
they had to
regulated
be, yeah,
Yeah.
because they were so important. And then, like, how do you even begin to start thinking about upgrading something like that? Has to be sort of like, I mean, how do you even maintain something like that?
Well, so there's different.
I just want to say that you and I have got a customer that we
Yeah.
both know of who happens to have elevator controls running on Windows XP that take human beings 2 kilometers into the earth.
Yeah,
And those Windows XP machines are not air gapped. They're running on an OT network that is on a IT network and segregated by nothing than logical controls.
So I think it's just, and go back to the nuclear example, right? So that's a highly regulated sector with very stringent segregation requirements. So there, what you'll see is technologies such as a data diode, and data diodes really originated in our OT space. Actually, out of Israel, Chris is one of the first founders of data diodes, and that's to create that one-way separation between those sectors. I think when you look at moving into some of the other industries, such as manufacturing and pharmaceuticals and chemical and everything else, where maybe you don't have the regulation, then it's a different discussion of in terms of how you're doing refreshes, but also how you're doing digitalization initiatives, such as Industry 4.0. Like I mentioned, that it's such a global space anymore. If we go back to COVID, we all saw the criticality of supply chains, right? And how the world was so intertwined and connected, and how supply chains affected the entire globe. So that highlighted much of the risk within these different systems and subsystems. But it's absolutely fascinating. Now, having said that, I think when you look at threats across much of what we call the discrete automation versus process automation, and I'll give you a 30-second definition. So think of a discrete automation as any process that has a distinctive start and a stop. So a manufacturer that's doing a production run. Now, I'm going to produce 10,000 widgets in this production run, right? At the end of that, it shuts down the line. A process automation is a continuous process. So think about a brewery or a chemical reaction, right? Where it's a continuous feed coming in, and a chemical reaction occurs on the output. So that's a process that just never stops. So that's the two different worlds. And then there's another one around energy management, which is the generation, transmission, distribution of power. So all of these have the commonality of basic element controlling a cyber physical process through the form of inputs and outputs. So when we're looking at what are the risk of these systems, typically what you can look at is what about the layer of where PCs with Microsoft operating systems are interfacing with the machines, or the things that tell the things what to do, right? That's that critical layer in between. And like you mentioned, Nicholas, maybe that's a Windows XP. Maybe it's not even that modern, right? But that's that critical layer. So when we're thinking about some of the vulnerabilities of these things, our best opportunity of securing them is, number one, thinking about the segmentation or segregation of IT from OT, or where the carpet meets the concrete. The next logical step in a pragmatic solution is have strong controls where the PCs are intercommunicating with the things, because that way you can actually use policy to mitigate the risk of some of the current state vulnerabilities, as well as what I guarantee will be some of the future state vulnerabilities. It's about tools in your toolbox.
But is there a human element to this? There has to be a human element to this, right?
There always is, right?
There's only so many policies that you can put in place that are going to stop people from being just, I'm looking for a word, but it's a swear word. And I don't want to say it. How do you stop people from being
unintelligent,
bad people?
Yeah.
Like, you know what I'm saying? Like, because sometimes like disgruntled employee, or somebody who's just plain stupid, for lack of a better word. So you've got these somebody pressed the green button instead of pressing the red button, or something like that. I mean, you've obviously got things where somebody's been fired, or there's something somewhere, or something like that. How do you, because essentially we can be the handbrake, but we can also be the accelerator, right? And then now I'm going to throw this in to this because we had to have you can't have a podcast nowadays without saying AI. What happens if there's like that thing now is coming in, and then fundamentally you've got all of these processes like power generation, food packaging, logistics. And so you've got either a stupid person or you've got a really intelligent robot. Like, this is scary. like where do you stop those things?
No, I think it's a really good point, because I think the reality so there's a lot of FUD, fear, uncertainty, and doubt, in my space. probably even more so than the general enterprise cybersecurity space. You know, I think number one, it's looking at all of the nation state attacks on critical infrastructure. Let's take a step back away from that. I think the bigger threat versus the nation states outside of the critical infrastructure slices is really the general ransomware and how ransomware has targeted manufacturing now. And we're dealing with the ransomware as a service. We're fighting a business model now. But the reality, to your point, is the biggest threat still is the insider. And that's not even malicious, it's non-malicious. It's a user that was intending to kind of short circuit a process to do their job, you know, effectively, and they paid a price for that, right? And making up, and that's what causes downtime. And that's a fascinating area in the OT space, because when you look at downtime, the cost of downtime is usually what really surprises the enterprise more than anything else. So let's just say that you're a tier 1 supplier to an automotive manufacturer. So how this works is all the vendors that make the different parts that go into the automobile, they build their factories right around the assembly area, right? And they utilize what they call just-in-time manufacturing. There's zero inventory. But what that means is any downtime causes a stoppage of all the vendors. So there's huge SLA fines for this. So you can look at $30,000-$40,000 a minute for downtime. Wow. It can be astronomical. So the insider, and this is how the automation world has dealt with that insider and ensuring things are done in a safe and effective manner for a while. Now introduce the malicious targeted attack, and that's a whole nother challenge, because that inside knowledge, you know, often that's where someone can really understand how to really
know exactly which piece of the line to hit that's going to cause the problem.
But it also poses some interesting challenges in terms of going beyond our typical, you know, annual cybersecurity awareness training, right? Or doing some tabletops, because in order to keep all of these automated processes running, sometimes we're dealing with very complex machines, very complex. So what will typically happen is the vendor or the OEM that created the machine will have service level agreements where they maintain support for that. All right. So what that means is remote connectivity. You might have that from different automation vendors, but also what we call integrators and solution partners. It takes an army, it takes a village, truly, right, to keep this going. So we're introducing all of these different remote capabilities, and that leads us into the supply chain and third-party risk component. How secure are those systems that are connecting in, and are they introducing some additional risk that can? And what is the definition of insider? Is it just the operators at the facility or our partners, right? So when we're thinking about training, we need to have the privileged user training for that automation system and what that means and how to safely operate. What are the safeguards in place? But we also have to think about operational technology, system-centric awareness training on an annual basis. So training becomes a much more advanced and critical component. It's a great point.
Yeah, I'm definitely starting to sense or think along the lines here of, you know, I can imagine way back in the 50s or whenever the first sort of, you know, industrial control process was created, IT networks didn't really exist at that point, right? So things were very standalone and isolated. But I guess over time now, it starts getting much more cost effective to start using, you know, Windows or something like that, a pre-written stack to run some of these things instead of having to build and manufacture your entire own process. And by doing that, I would then think that you're going to be introducing a lot more risk, because now you're connecting the world of your IT networks and your IT systems and your vulnerabilities in Windows and things like that to this previously air-gapped or slightly safer environment. Would you say that's accurate or an accurate statement? Is that sort of what we're seeing happen?
It's an interesting path, but there's a, often we'll use that term air gap. And first of all, Chris, I really hate that term because I've been doing this for 30 years.
Scratch
now.
air gap.
Well, I don't think I've ever seen an air gap system.
Right. No, that's fair. That's
fair. And listen, I think what's really interesting there's this notion that the OT world follows behind IT in terms of the tech stack by about 7 years. It's not necessarily that they're a laggard. It's more like parallel universes, right? Where they're often they're using engineering principles. And what I mean by that is so, for example, in the late 90s, I remember at Siemens, we were developing web-based SCADA additional capabilities, right? Where it was a web server based and web clients and doing thin client technology, right? We've been using Microsoft Windows based operating systems. Wow. Okay, I'm going to go back to the late 80s, right? Windows 3.1. So it's not a new thing. In fact, I would say 90% of the PC-based systems are Windows-based. You're starting to see a little bit more Linux out there, but that is the world that we've had. So there's always been a connectivity. Now, where I would say that it is much more connected now, Chris, is if we start thinking about the convergence of IoT, right? And the smart sensors. So now what you're looking at is everyone wants to get in on the OpEx subscription-based models. Instead of selling you a widget where I get that revenue when you buy my widget, what if I can have that widget provide some predictive analytics or something I can give you a subscription fee over time and you're the customer that just keeps on paying? That's the business I want to be in. So every sensor now is a smart sensor. So what's happening is now you're seeing dual communication mechanisms out of these sensors where you'll still have the read-write communication going through the I/O stack to the controller. But then you'll have another wireless interface that's typically maybe some type of the LTE wireless or some other mechanism that is connected to that vendor, right? And their cloud providing value-added services. Well, what this really means is you have all of these interconnections coming in. So our attack surface has literally exponentially exploded. So that's where does that make sense, Chris?
Yeah, that's a very interesting point. Right, I have this. So a couple of things there that just going to come to mind. So connectivity is becoming so cheap as well, right? Especially things like LTE connectivity. I live on a farm, and I've been looking at ways to put sensors on things that are not close close to the house, right? So I have a water tank down in the field, and I want to in the paddock, and I want to be able to monitor it. Or if I want to kick on a pump, I'm at the point, and it's like the decision tree for me is getting close to the point where it's actually cheaper for me to just run the sensors on LTE and have them report back in through the firewall than it is for me to try and extend Wi-Fi or extend Ethernet down to the middle of nowhere, right? And I imagine, I'm just doing this at a very small scale. I imagine if you're doing this at a very large scale, that would be a very, a big cost saving. But you also reminded me of this fantastic thing, and I hadn't thought about this in a very long time. So, this would have been probably, more than 20 years ago. I was working as a consultant, and one of my clients was a large engineering firm, and they did a lot of work. And this was in South Africa. They did a lot of work with mines and places like that. And one day I had a call to drive out to the middle of nowhere because I had to go and install some remote management software on a computer. And obviously at the time I had no idea what I was getting into. I just, gives an address. It's going to be 4 or 5 hours worth of drive from Johannesburg. Let's go. And off I went. And it turned out the computer that I was installing the system, the software on, and we're all old enough to remember good old PC Anywhere. Remember PC Anywhere?
Yes.
Yes. It was PC Anywhere. And this
first
computer,
team viewer, man.
It was used to remotely control a water cannon that was used to clean the inside of a smokestack. Great big, multi-story smokestack. And this, there was a massive high-powered water cannon in the inside that would run around and clean the soot. And this computer controlled that. And that thing had if you knew the phone number of the modem that was plugged into that computer, you could dial in, and that's all you needed, right? Now, 20-something plus years ago, but this is it's a great story that I was just reminded of when you were talking about that. I imagine some of those systems still exist, though, right? Which is more scary.
Yeah,
that's the very definition of security by obscurity.
Yeah,
Exactly. And I think it's interesting. I think one great example, Nicholas, of security by obscurity is the communication protocols. Right. So, how I used to tell the story to the enterprise security vendors is if you're familiar with the Purdue manufacturing model, think of it as these different layers that talk about the different types of components of a system, the type of communication. So at that level 0, this is your physical process, right? Your level 1 is your instrumentation. So think of level transmitters, temperature sensors, the motors, it's the things, right? And then the next level up is the control layer, right? So that's where it's running in a program, and it's writing to the outputs. In other words, it's turning on that motor when it should turn on the motor, and it's doing so based upon the level of that tank or that column of water, right? So it's operating a program. Once you get to the next layer up, now this is where you finally introduce the human user. And that's the HMIs, or human machine interface, where they're saying, okay, start this part of the process. And then the next layer up is SCADA, supervisory controlled data acquisition. This is where it's the larger plant level view. Now, the reality is, if you can come in remotely and you can manipulate the same behaviors of the operations, right? And then do so with having the ability to indicate to the operator that everything is running normal by resonating that motor, maybe stopping that motor very frequently, causing resonation. That is the definition of Stuxnet, right? So that's the big fear, I think, in the automated world, of a very targeted kind of nation state attack. But I think the bigger risk is, look at Colonial Pipeline, right? A couple of years ago. So I live in the southeast of the United States, and I'm telling you, the world went nuts down here. I mean, you had rednecks filling up the back of pickup beds with gasoline, just and it's like, oh my gosh, it was just crazy. You couldn't get gas. But when you look at this world and the security community and the OT, well, that wasn't an industrial control system attack. Doesn't matter. It stopped production, didn't it? Right. So if we think about the biggest threats being that coming from IT to OT, right? What you have to say is, as an adversary, and it's business now with ransomware, if I can affect your production scheduling system or automated warehousing management system up at that enterprise layer, that has the impact of stopping your production, isn't that the mission? Right. So do I really have to be advanced to get down to that control system?
That can happen nowadays with other stuff as well. Like,
yeah.
I mean, I don't know, like, you can see Elon Musk can post something on Twitter nowadays, and he'll have the same impact on a pipeline. Like, I've seen that the type of social engineering that's happening on X right now. I mean, he's like been banned in Brazil because he almost like shifted the elections, like just by saying some stuff on Twitter, which is the times we live in, right? So that we have to be worried about coordinated attacks on social media even. So, I mean, that's a pretty tough one. But from going back to like the whole IoT thing, I mean, it's not all doom and gloom, right? Because I think if I look at some of the solutions that are, let's say, available in Azure, and it's like shameless punt, but, we've seen things where it's sort of like a fetch-only protocol, for instance. You've got things like digital twins and those sorts of things where we've seen like bottling factories and things like that measure CO2 canisters and all that sort of stuff, where they use Azure or Microsoft's cloud, and you've got HTTPS protocols, and the stuff flies over, and it's got, certificate authentication, and it never it's one-way communication only. It's always outbound. So the device has to be authenticated, onboarded, then a configuration change is done. So you've got all of the authentication mechanisms like conditional access, and you've got all of the authorization as well as so you've got authorization as well as authentication all sort of happening up in the cloud, and then that device will poll for its config and then pull that config down from a specific location, as opposed to you being able to send a piece of config to that thing. I mean, obviously that's a step in the right direction,
I think Warren, you bring up a really good point. So we've kind of talked about, and naturally so, all of the bad things and the things that go boom, right? But listen, here's the good news. There is a silver lining there, right? So I talked about this earlier. And that is, as defenders, you guys from the enterprise space would be so jealous of what we have to work with on the OT side. Because, so let me tell you what that narrative is. When we're looking at the communication characteristics of these different systems, number one, you're having to deal with this nightmarish dynamic world where new devices are popping up continuously. We don't see new devices show up on our network. It's the same devices. Maybe an engineering or maintenance laptop will show up once a month plugged into a network. That's it in terms of change. It is known devices and it's known communication characteristics between a PLC and an HMI continuously. Now, you might have some seasonalities, but if you were to analyze, for example, with deep packet inspection, get all the way down to the operational codes or function codes that are being communicated, it's very consistent. It lends itself so well for actually doing things like anomaly-based detection, and behavior analysis, things that you could only wish of doing so easily on the enterprise side, we can actually do on the OT side, right? And then we can also have very engineering-centric response and recovery plans. So while we have all of these things that make it scary, the reality is it's highly defensible.
Yeah, that's cool. Okay, good.
So, look, I'm glad you said that, because Roger, because I think one of the things I wanted to sort of ask you was, if I'm listening to this now and I'm, let's say I work in cybersecurity for an organization, but this interests me, and I'm thinking, man, maybe the OT space actually is a little bit more interesting or fascinating or what have you. What sort of skills do you think, or would you say that I'd need to be looking at and considering and acquiring to kind of dip my toe in this space?
Well, there's a lot of, so I think that's a great question, Chris. So I think if you go back to academia and some of the younger generation, now we're starting to see programs at the university level, really focusing on, securing these systems. But I think for the enterprise security community, experienced professionals, there's organizations such as SANS and ISC Squared that have programs that are good. But I think when you look at, let's take a global mining or global manufacturing company, right? I think the best approach that I've seen in building out OT cybersecurity programs is by implementing cross-functional teams, where you take cross-functional domain experience that largely is coming from different aspects of enterprise security, combining that with process engineering and controls engineering and maintenance with the subject matter experts. This is the organic way of creating this specialized expertise that we need. So there's opportunities within a lot of these companies today of just joining the right advisory boards or cross-functional domains and getting that organic experience and getting that exposure. So, for example, Chris, one of the things when I'm doing like a corporate OT-based cybersecurity maturity-based assessment, I like to start with the corporate entity first, doing a couple of day workshop before we meet the plants. And often there's almost an army of the enterprise security folks that want to follow me to the plants and learn about their own plants, right? And they're always just so fascinated. But there's many opportunities today versus, just 15 years ago.
I think that the part of this I think that is really interesting for me is I imagine that you find security folks in these large manufacturing mining organizations all the time who absolutely have no idea about the OT side of their own environment, right? Because it's not something that they've come across or had to deal with at all. We have lost Warren, but
yeah, it's just my camera. My camera is just
okay. So we've lost Warren's visual, but here he is.
Not sure why my camera is deciding to go to sleep, but anyway, it's fine.
Oh, it's been a long week.
Yeah, my camera is just as tired as I am.
So Roger, you mentioned just before we kind of had the multicolored waves come up. We talked about you mentioned sort of some of the programs that you run for customers and stuff like that. Well, I mean, what can organizations do to kind of get better prepared for this? I imagine that most large manufacturing organizations already have some idea that this is something that they need to think about, right? But are you finding that there's sort of a lack of knowledge or lack of information, or generally what do you see when you talk to orgs?
So it's a good question, and I think it really depends upon the sector, Chris.
Okay.
So I would say go back to that statement of pre-Stuxnet versus post-Stuxnet, right? Immediately coming out of the Stuxnet world, I was building out the global industrial security program at Siemens. And part of that process was really trying to identify, what were the verticals that were the early adopters. And ultimately at that point in time, really resonated on chemical, because in many ways, oil and gas was kind of the bleeding edge of securing their infrastructure first. We already had regulation in the power sector, right? So there was elements of programs already there. So I think ultimately in that post-Stuxnet world, manufacturing, hey, listen, we're not critical. We're not convinced China and Russia are out to get us. And, so I think that was the point of much of that industry, and they weren't necessarily wrong. I think ransomware has changed that. By ransomware targeting manufacturing, now there's a financial motivation, right? So they're the ones that are probably playing catch up the most compared to other sectors. So, I think it's interesting when you're looking at an organization, a global manufacturer today, and let's say you've got 50 manufacturing sites across the world, more than likely, a good portion of that manufacturing came in the form of mergers and acquisitions. So you have different systems, different architectures, different philosophies of, we want to have a secure system versus we're not even thinking about it. So you have different layers within an internal organization. So I think the other trend that's kind of leading into that also, into those headwinds, Chris, is now we're around 80% of CISOs now being responsible for OT cybersecurity. So
okay, wow.
I think that's interesting, because when that happens, Chris, this is what it looks like. And the conversations I have, Roger, I'm trying to understand what I just inherited. What are the things that I'm supposed to be securing here? Because unlike the enterprise with the assets, IT doesn't own the assets. Operations does, which goes up through the COO, right? So there's a lot of challenges, but
that's very interesting, because I've talked to CEOs or CIOs and CISOs in the past, CISOs who have said, I've just become the CISO. I've just inherited all of this infrastructure, and I mean, that's IT infrastructure and IT stuff that they know about, right? So I can't imagine being in the position where I'm responsible as a CISO for OT and a whole bunch of things that, for the most part, I really don't have much idea about at all. So that can be very interesting, for sure.
Yeah, it all starts with just assessing what they have. Maybe doing some rudimentary things like some asset discovery, and having some asset management programs, because it's the old adage, can't secure what you don't know you have.
Well, that's right. Wow, excellent, interesting, so fascinating. Roger, want to be mindful of the time and obviously your time, and you're kicking off your workday, so we don't want to keep you too much longer. But before we let you go, is there anything that you wanted to sort of plug or I guess tell our listeners about? Can folks find you, LinkedIn, things like that? How would you
and tell them what not to do? Like I've got a lot of IoT stuff in my house.
Yeah, so just don't, Warren. Just don't.
Oh, so rather just turn the switch on myself. Like
No, it's hey, listen, we're all cyber geeks at heart, right here. Anyone probably watching this, so we're all fascinated with any type of automation.
But we're also terrified of a future where things are so vulnerable, and the doorbells that we have on our doors have got 11-year-old Linux kernels that have never been patched and that are exposed to the internet. And now we are terrified of the future where we've got older than Windows XP machines controlling beyond critical processes with water pumps and power stations and wind farms and sewage stations. And we need some hope, Roger.
Yeah, absolutely. Well, listen, there is hope, Nicholas. It's not all doom and gloom, right? So, like I said, the OT world is highly defensible. Number one. Number two, I think there's great hope.
It can be. You said it can be, but it's not.
It can be. But I think focusing on different aspects of segmentation and getting more granular. So, starting with that, separating where the carpet meets the concrete, IT versus OT, and then getting a little bit more granular, separating that process control network from the control system network. And then we can start thinking about things such as macro segmentation and micro segmentation. And that's really the true answer, I think, Nicholas, is having the dynamic ability to control different segmentation where we can isolate the impacts of different types of threats, right? Taking your doorbell as an example, right? I think that's some options where we can actually limit the spread. And I think that's really applicable to the ransomware, right? So for example, if I get attacked by ransomware, can I limit it to one factory instead of 20 of my 100 factories? That's a major difference in my revenue production.
I want to say respectfully though, Roger, that there's very few people like you who understand both worlds and who have the depth of knowledge to understand how a factory works and what the sensor means and what this control system means and how do I even secure it?
Yeah. And listen, Nicholas, I'd love to extend this conversation out to anyone. Obviously, I love to talk. So you can reach me on LinkedIn, Roger Hill. If you type in Roger Hill on your search, I'll probably be the first one because I think it's based upon size, and I'm a very tall guy. So, and then Hillstrong Security. So I'm the founding partner of Hillstrong Group Security. So please reach out. Love to talk to your company and see how we can help you secure your fleet of sites. Enjoyed the conversation, guys.
Very much so. Thank you for joining us. I really appreciate your time.
Yeah, and it shows me how much work and how much homework we still have to do to secure not only our doorbells, everything in Warren's house, which she's now going to be paranoid about, as well as all of the coal-powered power stations that are out there in the world that we hope just work.
Yeah. I think I'm more worried about the nuclear ones, to be honest, or like something that's like packaging my food, like that like, you know, stomach bug or like diarrhea is not so, yeah, you know, sorry, no. No. I mean, imagine that. I mean, that's a horrible attack. I'm sorry. Anyway.
Yes, let's all protect Warren's stomach. I think that should be our priority.
Thank you, Roger. Thank you for coming to the show.
On that note.
On that note.